Problems you want to see worked off the packet. Set the quizzes off to the side for a second. Problems you want to see worked off the packet.
Which packet?
Got two packets. Oh no, the other one's we said we were done with that.
Can we do 31?
31. Problem 31, they give. Real good. They give us a setup looks like this. How many triangles in this picture? 2. I would separate them all so that you can see them a little better. This is triangle, and my triangles don't look all that great, but let's go with it. AED. This is triangle A, C, and B. So I'll have to keep looking back at my paper. Do we know this length? 3. Do we know this length? Do we know this length? X. That's what we're looking for?
Yeah.
Do we know this length? Be careful.
No. 4.
6.
Which one is it? That whole length.
6. Yeah.
What do you gotta do there?
Add the
Add
2
them up, and
and
that's
4
why,
together.
that's why I would separate them. Alright? Do we know this length? No?
Some of it.
You know some of it, but not all of it, right? So we can't really put it in. Do we know this length? Now you're gonna set up your proportion. Do we have two sides that match up that we know numbers for them both? Yes, no, maybe?
2 and 6.
Does everybody agree with that? 2 matches up to 6? Yeah? And what's our second ratio gonna be?
X.
3 matches up to X? Everybody agree with that?
12 and X.
X is 12.
So what's gonna go on top? 12? So we come here.
Yeah. X and 12.
Oh, X.
Alright, make sure you're setting them up right. So if we started here and went 2 to 6, then when we do the other one, we gotta go X to 12. Make sure you're setting them up the correct way. We cross multiply, what's 6 times X give us?
6X.
2 times 12,
24.
divide both sides by 6, what's X end up being?
4.
So how long is this side in that triangle? 4. Next question.
39.
39.
It's like easy.
39 is 7'2" tall inch Margot. So we got Margot here, 7 feet 2 inches tall, 7 feet 2 inches. Is tall, one of the tallest women basketball players, professional players ever. Her coach, Carolyn Peck, is 6'4" inches. So we got Carolyn over here. She's 6 feet 4 inches tall. If Miss Peck cast a shadow 4 feet long, her shadow, every time, Allie, I'm drawing a picture for all these. I'm not drawing pictures because I'm such a great artist. I'm drawing a picture because it's necessary. And this is what you guys should be doing on your paper as you're reading these problems. How long is the other person's shadow? First thing with this, if we got feet and inches, can we really do set up a proportion that way?
No, converted to inches.
All right, so we probably want to change everything into inches. How do we change 7 feet 2 inches into inches? What's the conversion? 1 foot equals what? 12 inches. So all we do is we multiply the 7 times 12. What is 7 times 12?
84.
84. And then we add on what?
2 is just 86.
So there's 86 inches. Let's do the 4 feet, that's pretty easy. 4 times 12 is what? 48 inches. This one, we're gonna do 6 times 12. What's 6 times 12?
That's 72.
72. And then we gotta add what to that?
4.
4, what's that give us?
76.
76. Now let's set up our proportions. What are we gonna put on top over here? You guys make this harder than it has to be, watch. Here, 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 here. That's all it is every time. You're just matching them up that way and write them down.
86 over.
86 over what?
76.
76.
And then X over 48.
Do it every time. Don't make it harder than it is. The hard part should be drawing the picture. Gwen quit drawing little hair on her person and then a smiley face. Don't draw all that. When you doing that correct?
No.
Alright. 76 times x is 76. Somebody help me out multiply this one.
4,128.
Now, this number's in your calculator, right? We had this argument during intervention. If that number's in your calculator, what's the next step you're gonna do? Divide. So just hit divided by, and what are we gonna divide it by?
76, which is 54.3.
That's in inches. We probably wouldn't give it in inches since most of the time it's in feet and inches. I would probably accept that. How could we change that back into feet if we wanted to? Instead of multiplying by 12, what are we gonna do?
Divided by 12.
So you got that number in your calculator, divide it by 12 for it. About 4.5 feet. Next question, we probably got time for one more.
Thirty-four.
34. They give us 2 triangles. Sorry, I'm drawing them side by side instead of on top of each other. Something like this, that's 6. They want to know the length of BC. Where's BC at on this other triangle? So we'll make that X. What goes here? 8. What's it match up to? 8 matches up to 6. What are we gonna put over here in this one? 12 matches up to X. Well, where's the 10 go? We don't need it. 8 times X equals 72. Might help me out, what's X equal? Got about 15 minutes to finish those 2 quizzes. Can sort of help each other, but as soon as I see somebody just copying down somebody else's answer, you're done. Then you're working by yourself. 15 plus 19, what is that, 22? 22, so 122 you got till?
15 plus 19?
You got to 134. We'll do a few of them that you want to see.
Could do.
Oh, first let's do this. See if anybody actually watches the videos. Cross multiply when you get there.
8x.
Have your calculators out so we can go through this real quick. That way,
72.
we just got done doing this problem on one of them, then that was the same setup as one of the other problems we was doing.
9.
Might help me out this way. 286.
Yeah.
Divide by 9.
31.7.
31.7,
31.8.
8.
Cause it's 7 point.
I hope that's right.
0.7.
First thing on this one, put parentheses around this. Cross multiply that way, we get 3, parentheses, x plus 3. I know Joey's probably still not doing that, but oh well. 10x going that way.
You get 3x plus 9. Equals 10. Minus 3x. Equals 7.
Just cancel out, you're left with 9 equals 7x, then what?
Divide. Or leave it. It's 1.2857.
And if you gave the decimal answer, I'll probably be alright with that, but it'd probably be better off to leave it as 9 over 7. Easier that way. Scale factor, all you gotta do is find scale factors, match up to the sides.
2.
What's the match up? Give me 2 that matches up.
12 and 6.
If you left it that way, I probably wouldn't do a big fit, but that would reduce to 2 over 1.
Length of RT is 4 centimeters.
So if we, and you could probably do this in your head, but if we set up the proportion, we could do 12 over 6 and what over RT? 8 over RT there, and X ends up, or RT ends up being how much? 4.
Measure of R is 36 because if you add, well, the angles match up no matter how, like, you know, the change of it. So, but if you add 62 plus 82, it gives you 144 and subtract by 180.
So we find this angle, it's gotta be this angle, you want to say this?
36.
Perimeter with perimeter,
You add
All the
all the
sides.
sides.
so what's, perimeter QRT, that's the bottom one, right?
I got 15 for that.
So when we do this, don't be messing up today. When we do this, remember it's gonna be side from 1, side from 2, over perimeter from 1, perimeter from 2. Give me a side, we already got sides that match up, what were the,
12 and 6.
and Sam said that that reduced down to 2 over 1, right?
Yeah.
So we could do that to make it easier to multiply. What's the perimeter of the big triangle? 30?
Yeah.
Could we figure this out? If we want the perimeter of the small triangle, could we figure it out without really doing all the cross multiplying?
Yeah.
If this is 2 to 1,
30 to 50.
so perimeter is
50.
15 centimeters.
Yeah.
Area,
It says like 10.5.
gotta be careful on this. I hope all you guys didn't just do that. Area, we had a formula. Is this the height of this triangle? Is that the height? The formula we had, just like this one, side from 1, side from 2, area from 1, or area of triangle 1, area of triangle 2. Thing that I always forget to do, you've got to square each one of those. What was our side from triangle 1? 12 squared. What was our side from triangle 2? 6 squared. What's the area of triangle 1?
40.
And area of triangle 2, we don't know. Help me out, I'm gonna have to
144.
rewrite this. That's 144, that's 36. I'm gonna rewrite it up here. I know this is sloppy, but 144 over 36 equals 40 over A. Cross multiply, you get 144A equals, somebody help me out, 1,440. Divide both sides by 144, what do you end up with?
10.
So what's the area of this triangle?
10 centimeters squared.
10 centimeters squared.
I didn't do that, but I still got 10.
Did, so you got lucky.
Apparently.
For this to be a height in this triangle, what would this angle right here have to be?
90 degrees.
90 degrees, it'd have to be a right angle. On the packet, which problem did you say?
33, since it's a word copy.
33. Mr. Smith is having some photos enlarged for his studio. He wants to enlarge a photo that's 5 by 7. Probably a picture of me. Probably wants to enlarge those. 5 by 7. The new photo, he's not making it big enough though, is he, Joey? It'd be a lot bigger for Ebersole. It's so pretty.
What number is this?
33. So it's 5 by 7, he wants to have it 3 times bigger. What's this side gonna be in the new photo?
15.
What's this side gonna be?
21.
How many times larger than the original photo will the area be? The sides are 3 times bigger, but they wanna know how much bigger, or how many times bigger the area is. So in other words, how many of these photos will fit into this photo? How can we find the area of this rectangle here?
5 times 7.
What is that?
35.
How can we find the area of this rectangle?
15 times 35.
Somebody help me out.
315.
How can you figure out how many of these will fit inside there?
Divided by 35.
315 divided by 35. What is it?
9.
9 inches.
So how many times bigger is it?
9 times bigger.
It's 9 times bigger. Still not enough. It's a picture of Ebersole. It should be about 50 times bigger. Cover up Joseph's whole wall. Right at the foot of his bed so he can stare at me. Right, Joseph?
Sure thing.
Next question.
30.
30.
33.
32. 32. Looks something like that. They tell us this angle is congruent to this angle. Is that enough to say the 2 triangles are similar?
No.
No, but what do we know about these 2 angles?
They're vertical.
So they have to be congruent. Now do we have enough to say the 2 triangles are similar?
Yes.
That's 9, that's 6, that's 5, that's 11, that's X, that's 19.8. Pick me a side in the top triangle.
9.
9. What's 9 match up to in the bottom triangle?
19.
We did this one in intervention. I don't know if we set it up right or not.
We set it up differently.
So we better make sure that we had it set up right, because since we did this one in intervention, those of you who were in
We
here.
did 11 to 5.
What has to happen to get this triangle to match up to the bottom one? You gotta rotate it around. So we want X in our problem, right? Is X gonna be on top or bottom?
Bottom.
What's X match up to in the other triangle?
6.
5.
Which one is it, 6 or 5?
6.
Because this has to rotate around, correct? So the 5 actually matches up to the what?
Yeah, because I tried to tell Abby that it was, when she did it, she just took it and
Did
flipped
she
it
just
down.
flip it over?
Yeah. And I
So did we
tried-
do it wrong in intervention?
Yeah, we did.
Oh, we
So
did.
I
Wow.
redid it.
What's
But-
9 times X?
9.
Somebody help me out, what's this?
118.8.
0.8. Divide both sides by 9.
13.2.
Next question.
44.
44.
Good choice, Glenn. I saw something you did.
Should have picked 40. Well, no, I did 41.
They give us a picture, it looks like this. That's 8 meters, 12 meters, 9 meters. About how long is the log that goes across the creek? I'm guessing that's this log over here, right? So that's X. Is that the right one?
Yeah.
they tell us that this angle is congruent to this angle, and this angle is congruent to that angle. Are we just gonna flip this over?
No, you rotate
It's
it.
gotta rotate around again, doesn't it? So match them up for me. What on top? What?
12
12
and 9.
matches up to 9, so here to there, then what?
8x.
8 to x. Cross multiply, we get 12x.
72.
Now what?
Divide.
What do you end up with?
Six.
6 what?
Meters.
So how long is the log?
6.
6 meters. It's about this long, right? How long is it?
6 meters.
Give me an idea.
Isn't a meter
Like,
three?
I
Or
can't,
like
maybe
3.3 feet?
Me from the wall, tell me when I'm about 6 meters. There?
No, keep going.
It's up against the wall.
Yeah.
This is a meter. How many of these do I need?
So you need about 3 more.
I need 6 of them, right?
You need about 3 more. You need to keep going.
I told you 6 meters.
Keep going. Right about there.
Oh, I don't think.
Maybe about this long.
Right about there.
Approximately, how many feet is 6 meters?
18.
About 18 feet.
Good job, Joey.
How'd you?
Just 3.
You can do that so fast.
So, this is a meter stick. This is a yardstick, 3 feet.
I was gonna say,
The meter stick is about that much longer than a yard. So a meter is about this much farther than a yard. So just to get a rough estimate, about 6 meters is about 6 yards. A little more than that probably, but, or not probably, but it is. Hang on to those. We're going to do something with them next time. What I want you to do over here, 3 piles, two over notes. You got a packet there that's going to be your assignment tonight. Grab those 3.
he wants to turn in the quizzes.
We've already turned in the quizzes. Where you been?
You cheater?
He did. He cheated, didn't he? Daggone it, Joseph.
Come on. Eat it. Come on, take it. Take your punishment.
Joseph's a big cheater.
You said hold on to it until you turn. Move out of my way, and I thought, I was working on the packet, and I didn't hear you say turn them in, so I just kept. So funny, Gentry.
Because Ebersole never said that, did he? Never. Yep.
What about
match
Aaron?
up, Billy.
It's all messed up now.
Yes. His notes match up.
It
The
must
holes
have.
match up.
Because I learned from this one better than.
Oh, yeah.
Proportionality theorems.
It's gonna hurt so bad. For me.
I wasn't sure if I wanted to go over these or not because these confuse some people. When we have those triangles, like we just had a minute ago, where we have this, and we know that that little triangle is similar to the big triangle, and we can match up the sides and set up our proportions. There's other ways that might make it a little easier to do it sometimes, but it seems to confuse a lot of people. So you gotta know when you can use these theorems and when you can't. Right? Fill in what you need to fill in on mid-segment. There might not be anything to fill in except for the title, I think.
Yeah.
We did mid-segment earlier this last 9 weeks. What do you know about segment MN? If it's a mid-segment of this triangle. So those two are congruent, those two are congruent.
It's parallel to C.
So it's parallel to this. And what else? So it's the same length as this one and this one. So if I told you that this mid-segment was 12,
You can add one more slash.
If I told you that was 12, how long is this segment? How long is this segment? How long is this whole thing? 24. What if I do this? Does everybody see those two angles that I'm tracing?
Yeah.
What's going to be true about those two angles?
They're congruent.
They're always going to be congruent. Could I do it this way?
Yeah.
Yeah, and get the same thing, that these two angles are going to be congruent, so on, so on, so on, and that works for all of those. Those are all things, we learned all that with, when we did mid-segments earlier, in different chapter, just wanted to go back over it. The first proportionality theorem. Fill in what you need to fill in there, then we'll talk about it. All of you understand that these are supposed to be segment symbols, right?
Yeah.
Yeah.
So that's not, I know it looks confusing. Try to figure out a better way to do it, but can come up with any better way. So this one says this. If I have a triangle, whatever that triangle looks like, this doesn't have to be a mid-segment. If I just draw in some segment here, and it's parallel to that side of the triangle, guess what's going to be true about this top triangle and the big triangle? They're going to be similar. Alright? That's what we've been covering. So we could separate it and say, okay, match up the parts from that triangle, match up parts from that triangle, and set it all up. This theorem says this. Segment AD, which is right here, we can set up a proportion or a ratio with it with just this bottom half or bottom part of the segment there. So we just got done doing a problem where to match up or set up our proportion, we had to do what with those two segments?
Add them together.
Had to add them together. This is saying if these two are parallel, you don't have to do that. You can set up this over that has to equal this over that. Alright, so then you wouldn't have to add them together. So if Allie has trouble adding, she might want to not add them together. Just say this over this, this over this. So if I gave you this picture and this was 2 here, 1 there, 6 here, and X there, we could set up a proportion that says 2 over 1, this over this, equals 6 over X. And solve, and it's going to tell us that length right there. We could also do this. If you didn't like this, if you don't like this theorem, you could say 2 over, what's this whole length here? 3. Equals 6 over, what's this whole length over here? Be
6X.
careful. Be careful. 6 plus X. And then we could solve that. That's a little tougher than the other one. But maybe Sam doesn't like this because it's going to confuse her. Then set up the old way. Alright? So that's one of them. Find these on your paper there. We're trying to find segment QR. So that's our X. Tell me the proportion we can set up. X over 9 equals 4 over 6. Ignore that. Cross multiply. What's X times 6? 9 times 4? 36. Divide both sides by 6. What's X? So that part right there has to be 6. This is our X there, set that one up for me.
44 over 35.
All it is every time is this over this over this, or the other way around.
36 over X.
36 over X.
44.
44X. And
1,260.
then what are you gonna do? Divide both sides by 44. What's X equal?
23.6.
23.6, anybody else get that?
No, I got 28.6.
Oh, my bad, I was looking at the wrong.
28 point what?
6.
Yeah, that's what it
6.
is.
Yeah.
My bad.
Next, the converse of that. I don't even think I had you write anything down on this.
I just wrote it.
No, you didn't.
I did already.
There isn't anything
The
right
converse of it. Nothing to write down on this because we don't use the converse of it very often. So it's just going backwards and saying, all right, if you know that these are proportional, then these two segments have to be parallel to each other. The next theorem. If you have 3 or more parallel lines, so not just 2 parallel lines now, in this picture we got 3. You could have 4, 5, 6, 7, 10, whatever. And all these, I'm going through these quickly just because they're easy. All you're doing is setting up proportions still. Still the exact same thing that we've been doing.
I think you forgot your sink was in a little cold.
Hear that noise? Lily's great falling. She's kicking up on little silly stuff like that.
now. I knew what you meant. That's on all you put it. Unless it's like a test or something. 'Cause I know that.
So with this one, what you might draw in this picture, you're just going to put this over that length. So this length over that length, this length over that length, and set up that proportion. Now, for whatever reason back here, Gwen likes to be contrary. So if this is 5, this is 7, this is 8, this is X, and she doesn't, I hate doing it the way Ebersole says do it, then do it this way. 5 over 7 equals 8 over X. That's your proportion you're going to set up.
That's so much smarter.
Yeah, that's way easy.
Yeah, that's
Now,
way easier.
that works until I do what?
The
You're
other.
gonna make some kind of.
Until all of a sudden I turn it around and the picture's going the opposite direction.
Wait, I don't get it.
So now, it's this segment on over top of that segment, this segment over top of that segment. So if the picture's turned around sideways,
I just turned my paper.
exactly, then you can turn your paper like this if you want. The bad thing is, it's on the board up here. Can't turn it.
I was like, what?
I didn't think I had to say that. First thing we need on this, if this angle, angle 1, angle 2, and angle 3 are all congruent, what do we know about these 3 lines?
But they're parallel.
They're parallel to each other. Now, if they're all parallel, tell me, and we're looking for GH, which is right here, so we'll make that X. Tell me the proportion we can set up. What to what?
I don't know.
See, I turned it around on you, didn't I?
Would be E over D.
Tell me numbers.
300 over 150.
300 over 150, will that work? Yeah, you can do it that way. And then what's the other one gonna be? X over 120. Does everybody see that?
Yeah.
Don't make it harder than it is. On these, when you're getting big numbers like this, you might want to reduce this down. What'll go into both 100 or 300 and 150?
It's 2.
150 will go into 150 how many times? 150 will go into 300 twice. We probably don't want to just put 2, because next, what do we have to do?
Also reduce
You got to cross multiply, right? What's 1 times x give you? 1x. What's 2 times 120 give you?
240.
So how long is this segment right here? 240 what?
Yards.
Yards. This time we'll find BD, which is right here, so that's x. Tell me how to set up this proportion. What to what?
40 over
40 over 30. That's this over this. Then what? 16 over x. Cross multiply, we get 40 times x. What do we get going the other way?
480.
Now what? What is it? So BD is 12. Nothing really hard about it.
What did you do? 40.
30 times 16.
Okay.
I guess, I don't know. I didn't multiply, I'm hoping that's right. Is it right?
Yeah.
Last theorems. Actually, there's 2, this one and another one. If 2 triangles are similar, the lengths of the corresponding altitudes. When you hear the word altitude, write this in there in your notes somewhere. As soon as you hear altitude, what should you think of? Right angles. So that means it's something inside the triangle. Doesn't have to be inside the triangle, I don't guess. That gives you a right angle there. That's the altitude. It's actually the height of the triangle. Then the lengths of the altitudes are proportional to a pair of the sides. Notice I must have got to Lily Joseph. She didn't mention it this time. She didn't want her grade to fall anymore, did she?
He always laughs at you, always. Everything, little
Not
thing
even
you
funny.
do.
It's only because he
He
needs.
always-
What?
It's only because he needs a better grade.
Wait, what'd you say?
I just
I
laughed
didn't
because
know.
I laughed because it got super quiet. That's all. I thought it was funny how it got super quiet.
Next one, triangle bisector theorem. If an angle in a triangle is being bisected, so if we have any triangle and one of the angles is being bisected, you can set up these proportions. And when you set them up, all it's going to be this side of the triangle over that part down there of where this ray's going through. So that part of that side. This side of the triangle over that part of that side. Every time. Now in the bottom one here, some of you again just like to be contrary and want to set it up a different way.
What is
Means like
different?
go against what I'm saying.
Oh, okay. I was
So-
like, he's been saying it like 5 times already.
If you don't like that way, so Jalea's looking at this, and like she said on the other one, You could set it up this way. I draw a fraction bar here, x over n equals what?
Y over Z.
Y over z. So you could set it up that way also, it's still the same thing. Does that mean you can just set it up however you want?
No.
No, it's still gotta match up. And here I actually wrote it out in words. Side that's, I don't know why I put part there. Oh, yeah, I did. So side that's adjacent to part one, those two, and then the other two matched up. I don't know why you'd ever want to use those words, but somebody brought it up last year, year before, or something, so I started putting it on there. Set up this first one, a little tough on this one. Joey, you with me?
Yeah.
A little tough here, Joey, so I'm probably gonna need some help from somebody smart. Is that you?
No.
All right.
He said all
He's
right.
If I just take this side, 17, I could put the 17 over top of what?
It's
13.
7.
It's,
It's 7.
Or 7, not 17, sorry.
Okay,
Is
I-
it raining here?
So, 7 over 13. Now, here's where you gotta be careful. The second one. The 7's attached to this part. How long is that part?
Wait, what part?
The whole thing.
The whole thing's 15, so is that part 15?
No, we don't know.
We don't know it, do we?
So you're that, so
But we already got an X, so we can't just put X there.
you have to solve.
How can we-
bottom triangle first.
How can we do this? If we know this whole thing's 15, this part's X, how can we fill in that part?
Divided by 6.
15 minus X. So that part's 15 minus X. And what's this part down here?
X.
Now we have a proportion that we can solve. We cross multiply, what's 7, what's that give us? Multiply that way.
7x.
The other way I write it out, 13 times 15 minus X.
Which would be 195.
So
X.
you got 7X equals
195.
195. Now be careful.
Minus X.
Minus 13x.
You gotta distribute that out to both of them, right? So minus 13X. Now what are we gonna do next?
Add 13.
Sorry, I'm just rewriting it down here because I'm running out of space up there. Add 13X to both sides. What's left over here on the right?
195 equals 20X.
20X on the left. Now what?
Divide.
Divide by 20.
Which would give you
9.75.
9.75. Should we round that off?
No.
No, it comes out pretty nice and even. Just write out that extra number. Oh, a little tougher on this next one too. We got radicals, those square roots. We dealt with some of them last class. We set up our proportion. Remember, it's side compares to the part attached to it, side compares to the part attached to it. What's gonna go here?
4.
4? What's it compared to?
4 times the square root.
4 times the square root of 2. What goes here?
4.
4. What's it compared to? Ignore that.
Y.
Now we cross multiply, you get 4y equals, remember when you multiply this way, what do I multiply that 4 times?
The square root of 2.
2.
4
Wait.
times.
It's a
Wait,
regular
what about-
number.
where are we?
This is a regular number,
Oh, you have to find what the.
so you just, here, it's like this, 4 times the square root of 2. So what's that give me?
16.
16 times the square root of 2. Now what? Forget that square root of 2's there, you guys let it bother you. What would you do next?
Divide by 4.
Divide both sides by 4. Even with that square root of 2 there, guess what you do next? Divide by 4. You can't divide 4 into the square root because they're two different kinds of numbers. But you can divide the 4 into the 16. What happens there?
Just 4 square root of 2.
4 times the square root of 2, that's your answer.
So you kinda just forget it's there and just work around it.
Right, it's sort of like having a variable. Alright? So when we're doing something like this, when you did this in algebra last year, 4x times 5. What'd you do there?
Multiply the 4 times.
It'd be 20x, right? You sort of forgot the x was there and just wrote it down at the end. Now let's go back to this. Look at what you had here, so that you don't have to do so much work sometimes. Do you notice anything about the two numbers that are on top? They're the same. If these two numbers on top are the same, guess what's going to be true about the two bottom numbers?
What is saying?
They're going to have to be the same. Did it come out to be the same?
Yeah.
Yeah.
So instead of doing all this work, we could have just looked at that and said, hey, that's got to be 4 times the square root of 2. There were some of the problems on that last packet that were like this. 10 over 75 equals 10 over x. Well, what's x have to be there?
35.
That's the only way that this fraction can be equal to that fraction. If the two top numbers are the same, the bottom numbers have to be the same. Alright? So make things easier on yourself. Find these. A little tougher now. A lot tougher. We're going to put parentheses around these two. We're going to cross multiply. We get 2x times x minus 3 equals, somebody tell me what I'm going to write down on the other side.
3x plus
3x
Parentheses, x plus 3.
Anytime you see something like this, what you're probably going to have to do, you're probably going to have to factor. We distribute here. 2x times x. What's that give you?
2x squared.
2x squared. 2x times a negative 3.
Negative 6x.
Ignore that. 3x times x.
3x squared.
3x times 3.
9x. Minus 2x on both sides.
Now, usually, probably when you were in algebra, you tried to get 0 on this side, everything else on the other side, right?
Yeah.
But if the bigger x squared's over here, then let's move everything over here and try to get 0 on this side like Lily just said. So let's subtract 2x squared on both sides. These cancel out. What's left on this side? Close.
Minus 6x.
Negative 6x. What's 3x squared minus 2x squared?
1x squared.
Just 1x squared, so just x squared. And we still got plus 9 over there, right?
9.
9x, sorry.
You add the 6.
What was that?
Add 6x on both sides. What's left on this side?
Nothing.
Math time, or math terms.
0.
0. On the other side, you got x squared plus
15x.
15x. If it helps you, turn it around. X squared plus 15x equals 0. Means the same thing. Now, the nice thing about this one, when we go to factor this, it's not going to factor out into the two parentheses like we had to do the other day with this one here. Because what we can do here is find a greatest common factor. What do both of these two terms share? They share an x, so we can take that out front. So everybody remember doing this in algebra?
Kinda.
You take an x out. If you take an x out, what's left in this first term?
Squared.
X.
Just an x, because x times x gives you x squared, right? You take an x out of this, what's left? plus 15 equals 0. That's in the factored form. Now, just like the problems we did just like this problem, you're saying this times that gives you 0. So either this parenthesis, let me write, either that parenthesis equals 0 or that parenthesis equals 0. So you just break it apart. Either x equals 0 or x plus 15 equals 0. How do you solve this first one?
X equals 0, so you just take it away.
It's already solved, isn't it? So don't take it away, because what could x be then? What's one of the answers x could be? 0. How do we solve this one? Minus 15. What's x equal? Negative 15. Those are our two answers. Either x is 0 or x is negative 15. Sorry, Julie, I got down there a little bit. I can go to Miss Barnes here in a little while and tell her that you guys remembered all that, right?
No. I think our grades show for how much we will remember from that class.
I had a great grade in class.
Next one, I put parentheses around these two. X times 4 minus x. On the other side, 5 times 2x plus 1. Somebody help me out. When I distribute here, what do I get?
4x minus x squared.
4x minus x squared. When I distribute here, what do I get?
10x plus 5.
We want to get everything on one side again. Unlike with just normal equations, we want to try to move everything to one side. The x squared is negative when it's on the left, so we probably want to move it to the right-hand side. If you can start, when you get to this point, if you can start doing some of this in your head, making everything a little simpler, a little easier, it's going to make everything go a whole lot quicker. All right? Like when I move this 4x over, I'm going to subtract 4x on both sides, right? Correct? So if I subtract 4x on this side, and I subtract 4x on that side, what's that going to leave me with over here?
6x.
6x, right? When I move this x squared over to the other side, what's going to happen to it? Instead of being a negative, it's going to become a positive. If you're not sure about that, then we'll do it one step at a time. So I'm going to add x squared to both sides. 4x, these cancel out, equals, can you put that x squared with anything on that side?
No, so you just add it on.
So you just put it on, x squared plus 10x, it's not a like term with anything, so we just stick it in there.
Does it matter if you put it before?
Yeah, we want to put it in order. So we want to go squared term, x term, regular number. Right, biggest to smallest. That's what you learned in algebra. Subtract 4x on both sides. What's left over here on the left?
0.
0 equals
X squared plus 6x plus 5.
do we want to turn it around again, or do you like it that way, or is it all right that way?
I think it's fine that way.
All right, so we're just going to set up our two parentheses. This time we don't just have a greatest common factor, because they don't all just share an x or anything, so we have to set up our parentheses. In the first two spots again, we look at this first term here. What times what gives us x squared? X times x. That's pretty easy. That's 99% of the time, that's what's going to be in those two spots. Then we look at the last term out here. What times what gives us 5? 1 times 5, that's it, isn't it?
Yeah.
So that's the only one that'll fit in there. Let's hope that works. So we put plus 1 plus 5. Then we check it. Remember the check, you do FOIL, but all we really need to do are the outer and inner terms. Outer terms, what's x times 5 give you? 5x. Inner terms, what's 1 times x give you? What is 5x plus 1x?
6x.
Is that what we had in the middle right here?
Yes.
So that means we did it right.
Will it always be in, like, will that number always have to be in the middle?
Yes, unless, let's go back over here. That's not good. Unless it's like this one here, where this leading coefficient was something other than 1, where it was 3 here in front of that x squared, then that's when everything gets all screwed up and you gotta guess and check and go through all that. Now, when we go to solve these, and Joey, again, I'm trying to make it as easy as possible on you, and Joey's going, what are you gonna write all that out and everything? All you're looking at, what makes that one right there 0? What would I put in here for x to make that 0? -1. That's one of our answers. What would I put in this one to make that one 0? -5. That's our other answer. My pen starts writing again. Sometimes you can't just look at it and see it that way. Sometimes you actually have to write it out and solve it. But if you can just look at it, do it. Make it shorter on yourself. If I was doing this problem, I would do this first part right here, all of this stuff in between. I probably wouldn't do any of this. I would do that, and I would write my answer. So I'd have like 3 steps. But I understand, Gentry, that's not you because you've not been doing it near as long as Ebersole has.
Do you mind if you hold on there so I can finish writing this?
No way.
Where did you get the x plus 1? Is it just the 1 from the x squared?
This x plus 1.
Yeah.
So
Where did you get the 1 from? Oh.
so when we set this up, these first 2 are going to be what this breaks into.
Okay.
So x times x. The last 2 are going to be what that last term there breaks into. So 5 times 1. And sometimes, if that number, if that plus 5, let's say it was plus 100. That could be 101, it could be 50 and 2, could be 25 and 4.
Is that when you start guessing? Like
That's when you have to start guessing and plugging in there and seeing. Get it?
Yeah.
Pick one. We'll do one of these. Which one do you want to do?
1 on the left.
One on the left. We put parentheses around this, put parentheses around this. Cross multiply. On the other side, I forgot to put parentheses around that. We got 1 minus x times x minus 8. You'd have to pick the hardest one. wouldn't you?
Then we can do the other one.
What's that give us?
2x.
What's this give us?
2.
Now, when we do this over here, we got to do FOIL. We got to do a little more multiplying. It's not really that much harder. It's just extra work. So FOIL first terms, 1 times x. What's 1 times x give you?
1x.
Outer terms, 1 times negative 1. 1 times negative 8 is what? Inner terms, ignore that. Negative x times x
0.
X.
times
Oh.
Negative x squared.
negative x squared. Remember, anytime you're multiplying an x times an x, you gotta have that squared. Negative x times negative 8.
Positive 8 squared.
Be careful.
Positive 8.
Just positive 8
X.
x.
Combine that terms.
What's 1x and 8x gonna give us? Is it alright if I just write that out here and we remember that it's there?
Yeah.
So that we don't have so many steps. Now what we're gonna do, we're gonna move all of this stuff from this side over to that side. When I move the x squared over, it was negative, so when it gets over here, what's it going to become? Positive. When I move the 9x over, it was a positive 9x, so now it becomes a negative 9x, and I'm putting it together with the 2x, right? So what's 2x and negative 9x give us? Negative 7x. I'm trying to make this short. If you start seeing this stuff, then it'll make it easier. When I move the negative 8 over, it's going to become a positive 8. Put it with the 2, and what do you get?
10.
And what's left on that side? 0. That's what we wanted.
Every time you cross the equal sign, you change the sign.
Change the sign. What are the factors of x squared? What's x squared break into?
X and
X and x. That's pretty easy. Then the other part, we got to find the factors of positive 10. Give me two numbers that multiply together, give us 10.
5 and 2.
5 times 2.
10 and 1.
10 and 1.
And then also negatives.
Negative 5 times what? Negative 2. Negative 10 times
Negative 1.
negative 1. We want the ones that added together give us this middle number right here.
It'd be negative 5, negative 2.
It's that one, isn't it?
Yeah.
So what do I put in here?
Minus 5, and then on the other one, minus
And if we check it, we do the outer and inner. What's x times negative 2? Negative 2x. What's negative 5 times x? Negative 5x. What's negative 2x and negative 5x give you? Is that what we had in the middle right here?
2.
Yes.
So that's the correct factored form. So just if you were asking, this is where you have to guess and check. But it's not just like some random guess. It's a guess using your brain. If this one equals 0, what can we put in here for x to give us 0 for this set of parentheses? 5. What can we put in this one for x to give us 0? What's our two solutions this time then? Remember, when you were doing this last year in algebra, what you were doing, does anybody remember what the graph of something like this looks like?
No.
It was this. It's a parabola. Right? So it looked like this. And what you were finding are those two spots where it crossed the x-axis at. Your assignment is that packet that you picked up. On that packet, it's none of this factoring stuff. I just threw that in there because we need to go over it. Because you got to know it. All right? It's a lot of the same stuff that you were doing, a little bit of the new stuff thrown in there from the parallel lines and all that stuff. Joseph, you ready? We got 10 minutes.